Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 23 in our incredible new tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice big mug of iced coffee, and I'm going to need you to get out your Jetson Nano gear. And while you're doing that, I want to give a shout out to you guys who are helping me out over at Patreon. You are keeping me in coffee beans, and you are an incredible encouragement to me. You guys that are not helping out yet, take a look down in the description. There's a link over to my Patreon account. Think about hopping over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump right in and talk about what we are going to learn today. What we're going to learn about is we're going to learn about bitwise and logical operations in OpenCV. And as we're getting into really starting to do the meat and potatoes of the artificial intelligence, and we're doing image processing and image manipulation, there's kind of some concepts that we need to begin to become familiar with. One is the idea of masking, where we apply a mask to an image and we just keep parts of it and we throw other parts away. And so masking allows us to do things like separate parts of an image from the background or to block out parts of an image. Along with the idea of masking, there's an idea of thresholding, where we have certain thresholds between what we're going to keep and what we're going to throw away. And then along with thresholding and masking is the idea of bitwise operators, where we kind of have logical functions that all of this gets thrown away and all of this we keep. And so those three concepts we're going to be building over the next few lessons: bitwise and logical operators, thresholding, and masking. And we will get into bitwise and logical operations today. And so what I need you to do is come on over and let's go ahead and open up Visual Studio. And then we are working in the folder. We are working in the folder PyPro. And then within PyPro, we are working in the folder. Let me close some of this stuff. I got too much stuff. Okay. We're working in the folder OpenCV. I am going to select the folder OpenCV, come up to our main folder PyPro, and click the little page with the plus on it, and we're going to create a new file, which we are going to call OpenCV, and I believe we're at 12. And then what we're going to call this is bitwise.py. The .py is kind of important. Apologize, you guys. I'm getting over a cold, and I kind of got over it yesterday, but still a little congested. But today is the day I have time to make videos, so we're just going to power on through and hope you guys understand that if I don't do it today, it'd be a few weeks before I could make some more videos. So we're going to do the best I can to do this, as I am a little stuffy. Okay, we're going to go to our standard program, which we get from the most excellent www.toptechboy.com. You can search with the little icon here, and let me go ahead and get out of your way. You can search with the little icon here and search on web camera on the Jetson Nano. You should come to this page, and then you can click on the little page over page, and then Control-C. You can copy all of this. And then we always start with that as the basic program which runs the camera. And then since I am using the PyCam today, I'm going to uncomment out this cam set and this cam line. If you're using a webcam, alternatively, you would uncomment out this line. Okay. And then the one thing I need to add is to keep my windows organized. I'm going to add cv2.move window. What window do I want to move? Nano cam. Where do I want to move it? To the upper left corner, which is 0, 0. Excuse me. Okay, so let's fire this up just to make sure we haven't broken anything. Okay, very good. There we go. We have our Raspberry Pi camera up and running. Okay, so now what we're going to do is we're going to start working on these bitwise operators. And you might be kind of familiar with this. Is kind of like the concept of and the concept of or and the concept of like exclusive or and kind of like to understand it, the and operator, like if you have a gate with two inputs, and means for the output to be 1, both of the inputs have to be 1. So if it's 0, 0, the output's 0, 0, 1, the output's 0, 1, 0, the output's 0. Only 1, 1 gives an output of 1. So the first input and the second input have to be 1 in order for the output to be 1. Similarly for OR, if either is a 1, the output is a 1. So a 0 and a 1 would give you a 1 and a 0 would give you a 1 and a 1 would give you a 1, and only 0, 0 give you a 0. And you're probably familiar with that from logic gates. We're going to apply that same thing to images, only instead of just having one logic gate with two inputs, what we're going to have is two images. And those two images will be like a matrix. So we're combining one matrix with another matrix, and then we get an output matrix where pixel by pixel we are doing that comparison. So to do that, we're going to need to create some images. And so let's do that up here. I'll just kind of jump in at the top. And another thing is we're actually going to be using matrices, and we view images as matrices, but we can build those matrices using our NumPy library. So I'm going to need to import NumPy as NP. And that'll give us help in creating and manipulating these matrices, which are really going to be images. So let's create our first image, img1, and that's going to be a matrix created by NumPy, so we're going to call it NP, and then zeros is just going to make a matrix that it fills with zeros. So all the values put in are going to be zeros, and now we got to give it some parameters, okay? So we're going to give it a tuple of the matrix dimension. It's going to be 480, so that means it's going to have 480 rows. It's going to have 640 columns. And then at each position, we are going to have one number. So this is kind of going to be a matrix where you could think of it as grayscale. So where you have the value of the pixel, it's just one value between 0 and 255. Now, if we were creating a color image, we would put 3 here because you would have 3 numbers, a blue, a green, and a red. But this is going to be more like a grayscale image. And so it's going to be 480 rows by 640 columns. And then it is going to have one color, which is going to be gray. And now we've got to tell it kind of the units or what the format for those numbers is. And it's going to be NP for NumPy, and then unsigned int, UINT, in 8-bit. So that's an 8-bit unsigned int is the type of number that is going to be there in that image array. Okay, now let's just for fun, let's display this. And since this is an NP0, all the values should be 0. And so this should be what kind of window? It should be a blank window, all black. So let's come down here and show it. Let's see what we called this thing. We called it image 1. So we'll come down here and we will do a cv2.im show. And then what are we going to call this? We will just call this img1. And then what do we want to show in img1? We want to show img1. Okay. And so that should show it. It should just be a black window. But let's move it so we can keep our windows organized. Move window. What window do we want to move? img1. And where do we want to move it? Well, we want to move it below the other one. And so I think that we would put it like over an X. Let's see. We would want to move it over an X0 and then down about 500 because it's 460. Leave a little bit for that bar on the top of the window. About 500 should put it right below our original image that we're getting from the camera. So let's take a look at that. I like to run these things every once in a while. Okay, there it is, and that looks pretty good. So I've got the main window here that's coming off the camera, and then I have this black window that I just created using the NP0. All right, let me quit out of this thing. And now what I want to do is I want to make that image, instead of being all black, I want it white on the left and I want it black on the right. So we can do a little bit of manipulation here. So I'm going to say IMG1, and the pixels that I want to change are between row 0 to row 480. So that's all the rows, and then from 0 to 320. So I'm going to get all the rows up and down. So that's going to be in the range from row 0 to row 480. And then going across, I want to go from column 0 to column 320. So I want to go from column 0 to column 320. And you see this colon, it's saying from 0 to 480, and then from 0 to 320. So that should be the entire left of that window. And then what do I want to set that to? I want to set it to a value of 255, which would be full on, so it should turn those white. So let's go ahead and let's run this Python file in terminal. Hey, boom, we got it. We got it white and black. I can't help but just play around with this. Let's see if we could make a gray. Let's say we could make it gray by making it 125. Let's see if that actually works. This should be a grayscale image now. Yeah, look at that. We made it gray. But in bitwise operators, really we want it on or off, and so we want it really to be the 255. 255. Okay, so that's image number 1. It's going to be white on the left, and it's going to be black on the right. Now we're going to create image 2, and it's going to be np.zeros, and this one is again going to be 480 by 540, and again it's going to be grayscale, so there's just one number there, and then it's going to be np.unsigned int 8, an 8-bit unsigned int. And this one, what we are going to do with it is we're going to put a little white box in the middle of the big black box. And so right now we have a big black box, but now I'm going to say image 2, and the range is going to be, I want row 190 to row 290, so that's going to be a box 100 big in the middle. So from row 190 to 290, and then from column 270 to column 370. So that'll be 100 tall and 100 wide. So this will be 290, comma, 370. Are you guys kind of getting familiar with this, kind of comfortable with what I'm doing? Now I want to make those white bits, so I would set it to what? 255. And that probably would be good to be in brackets. Okay. So now let's see if we can show IMG2. So I'm going to come down here, and I'm just going to grab this IMG1, these 2 lines of code here, and I'm going to copy it, and then I'm going to paste those 2 lines. And then what I'm going to want to show here is, instead of IMG1, I'm going to want to show IMG2. This should be a black box 640 by 480, 640 by 480. And it should have a white box in the middle that's 100 by 100. And then this one, I want to move over. I want to move it over like 700 to the right. And it will just be at the top. So 700, 0. Let's see if this works. And it doesn't look good. What is wrong? Oh, did you guys see what horrible mistake I made there? This is a range. It's not a comma. It's column 290 2, which is a column 370. Now let's try it. Okay. All right. But my image 2 is in a terrible position. I certainly didn't resize that right. So let's quit out of this and see what I did wrong on my move window. I didn't say image 2. It's img2. Did you guys catch that there? Okay, now I think this should work. Run Python file in window. I still didn't change that right. My copy and paste on my IM show, I showed IMG1 again where it's IMG2, right? That's the danger of copying and pasting. I didn't change everything that I needed to change. Okay, so let's look here. I think this time it'll work. Run Python file. Okay. I do not like the position of that, though. It should have been... I didn't do the white box right? It should be in the middle, and it is not in the middle. So let's see how we get this in the middle. I did not do my calculation right. So let's quit out of this. And let's come up here and look at this. Okay, that would be 190 to 290. And then it should be 270 to 370. 270 to 370. Because if you think about it, I want, if it's 640, I want to take 100 off of that. So 640, that would be 540. And then 540 divided by 2 would be 270. So I go from 0 to 270 and then out to 370, and that should do it. Get a piece of paper and scratch this out. You should be able to see why this would work for an image that is 480 high and an image that is 640 wide. And I want to put a 100 by 100 box square dab in the middle of it. So let's try that. That is still not in the middle. So let me see what I am doing wrong here. Clear. Quit. Okay, so let's see. 480 by 640. Oh, here it is. That was supposed to be 640. That was one of the errors there. Okay. Okay. So this image 2 is 480 tall and it's 640 wide. And again, when you're dealing with an image as an array, you go rows by columns. Rows are first. So I have 480 rows by 640 columns. I really hope this works this time. Boom. Okay. So here I am in the upper left, and then I have my first masking type box here as IMG1. Okay. It's white on the left, all ones. Black on the right, all zeros. And then here I have another masking image, which is black everywhere, zeros, except ones in this center 100 by 100 box. Okay, now let's start doing a little bit of bitwise operators. So let's take that image 1 and image 2, okay? And now let me create a new image called bit and, okay? And what bit and is going to be, it's equal to CV2 dot bitwise and, okay? And now what am I going to and together? IMG1 and IMG2. Okay, now remember, white is a 1 and black is a 0. So where is the white going to be in the new image? Only where both the image 1 and image 2 are white, okay? So if I'm going to do that, I need to show the bit and down here, and so I'm going to live dangerously and try to do better than last time. I'm going to copy those 2 lines of code, and then I'm going to paste them, and then I am going to show, I'm going to need, I'll call this the and window. And what do I want to show? That thing we just created, which is bit and. And then I want to come down here, and I'm going to move the window, and I want to put it below this one. So I'm going to go over 700 and down 500. What do you expect it to be? It was white on the left in image 1. It was white just in the center in image 2. Where are they both white? Well, that will be what's white in this image. Ooh, IMG 2. What is that? In line 9? How could I have an error all the way up here in line? Oh, man, were you guys screaming at me? I tried to do the and before I created image 2. I hope you guys caught that. Okay, this should work this time. Okay. Now you see this? This is white all the way on the left and black on the right. Then over here, this is white only in the middle. So where are they both white? Well, it's kind of like you split this on the left and only here are they both white. So this is, in fact, the AND operator. Now understand that it's these bitwise functions where you create these black and white regions. We're going to later use this as a mask so that we can mask things off and only let show through the areas that the white are. So like I could take this mask and I could apply it to this picture of me, or I could take this mask and apply it to this picture of me. But in order to be able to do that, you've got to be able to do these logical operators so you can create the mask that you need in order to do the masking function that you want. Okay, well, let's try another one here. If we did the bitwise AND, can you imagine what the next one would be? The next one would be a bit OR, right? Bitwise OR. So I'm going to OR those two together. And so this will be bitwise OR. And I still want a bitwise OR image 1 and image 2. So I will come down here and I'm going to get these two and I'm going to copy them. And then I'm going to paste them. And then I'm going to adjust them, hopefully correctly. And so this is going to be my OR window, and this will be bit OR. And now this one, let's see, how far do you think I should move this down? Let me look over here and see if I can come up with a good number. I think that I'm going to go over 1340 this time. I'm going to go over 1340, and then I am going to go down by 0, and that should work. Okay. And something is very much not happy. Okay. I see what. Okay, I didn't move it right. Let's see. Forgot to change the window to OR. All right, so this one I really think should work. Okay. So you see, this one is image 1 ANDed with image 2. This one is image 1 ORed with image 2. So here, this one is white if either is white. And I am going to probably switch over here to this view to get that little thing out of the way. Okay. I know you guys hate that little live inset image of the Nano, so I have moved it out of your way now. So that is the bitwise OR. Okay. Now, I'll just show you one that's another one that you can do. And let's see. I'm going to quit. And that would be the bitwise exclusive OR. An exclusive OR means the output is 1 if and only if 1 is a 1. So a 0, 1 will give you a 1, a 1, 0 will give you a 1, but a 1, 1 will give you a 0. And so that is the bitwise exclusive OR. So let's do that one. So I will come down here, copy. And I understand I am running out of space here, but I will say bitwise exclusive OR. And I think that is just going to be the exclusive OR, if I remember it right. And now down here, I'll just change that I'll add another one. Okay, so I'm going to come here, and then I will copy, and then I will paste, and I will make this one exclusive OR, and then what did I call it up there? Bit exclusive OR. Exclusive OR. Okay, and this one I'm going to go 1340, and then I'm going to go down 500. So let's look at what that exclusive OR does. Did I do that right? I hope so. What did I do wrong there? Man, I just keep making... it's the window exclusive OR. Let me quit that. Okay. This one hopefully will run. When I tried to quit, it put a Q in my code. All right. Okay. So you see, this is kind of interesting. This is the exclusive OR. So it is white when only one is white. So if the left is white, you're fine. If this right part is white, you're fine. But this became black because both of them are 1 there. And the exclusive OR, it's 0, 1, or 1, 0. It's not 1, 1. And that's why that became black. Okay. Now, what the real interesting thing is now we're going to take our first attempt at creating a mask. Okay. And so what I'm going to do is I am going to come up to frame. Remember how we grab frame? Frame is the image that we grab from the camera. Well, now what I'm going to do to frame is I'm going to I'm going to cut this out here and move it down to the bottom. Okay. So I will come down here now, and I'm going to, on this one, on my main image, I'm going to apply a mask. Okay. So let's say that I say that frame is now going to be equal to CV2, and then I'm going to do a bitwise and. Okay, I'm going to do a bitwise and I am going to do it on frame and frame. So there's a lot of different things that you can do with bitwise. Like you can do it bitwise with 2 different images, but here we're just working with 1 image, which is frame, so we got to list it twice. The new frame is frame comma frame, and then I'm going to apply a mask. Okay, and what is the mask that I want to apply? Well, let's see, what was a good mask up here? Let's just apply IMG1, okay? And then we're going to show the nano, and so this should just mask the image and only show where our mask is white. So let's try that. Run Python file in terminal. Okay, boom. Do you see here now in the upper left, we have masked with our black. We have used this IMG1 here. We've used this IMG1 as our mask, and we only show the image where the image is white. Okay. Well, what other thing could we use as a mask? We could use IMG2 as a mask, and now we're only going to have a little bit showing through that white window. Okay. So let's say run Python file in terminal. Okay. So you see now we're masking it with IMG2, and you only see through that real little window. Okay, let's do the XOR this time. And so we called that bit OR. Did we call it that? We called it bit XOR. All right, and now let's see what happens. Run Python file in terminal. Okay, you see, so this is kind of strange here. Okay, but we're applying this XOR as a mask on the NanoCam. Okay, now what we're going to be doing, so what we've learned today is we've learned these bitwise operators where we can create masks by combining different combinations of black and white masking to create a mask that we then use to mask a live image. Now, in our future lessons, we're going to create the mask rather than just using NP0s and creating shapes. Those masks will be created based on some property of the image itself. And so imagine that I was masking on something bright blue and I ended up with white, a white mask only where the tip of this blue pen is, and everything else is black. And that way I can mask out everything except for the thing that I'm trying to track or look at. Okay, so that is where we are going in the future. And to do that, we've got to learn how to do thresholding, where we generate the mask based on pixels that match some sort of threshold criteria. And then with the thresholds, then we want to go in and we want to mask the images to pull an object out of the background and to get rid of the background and just to be able to look at the thing that we're interested in and to be able to pull it away from the background. That will make more sense in future lessons. Let me tell you a little bit about some of the stuff that we have coming up here. We're going to be kind of taking images apart in the next lesson, where we're going to take an array that is our frame that we're getting from the camera, and we're going to split it into its 3 different color channels. So you remember that that image is just a matrix where we have rows and columns and then groups of 3 numbers for blue, green, red. We're going to show how we can pick out and show each one of those color channels individually, and then how we can put it back together into an overall image. So again, we're just learning how to rip apart an image and put it back together, and learn how to operate with it not as some mysterious object, but just as a good old-fashioned matrix, a two-dimensional matrix where we have rows and columns, and the intersection of rows and columns is a pixel. Okay, so that is what we are going to be doing in future lessons. I am wondering, did anyone make it all the way to the end of this video? You can show me that you made it to the end of the video by showing the magic word down in the comments, which is Eagle 10. This is an image from one of my students' recent space flights, where we send instrument packages to the edge of space. This picture was taken at about 120,000 feet above the surface of the Earth, and we were able to snap a picture just as the large helium balloon was rupturing. On the ground, the balloon is about 6 or 7 feet across. When it gets up to 120,000 feet, it's expanded to where it's 30 or 40 feet across. And we were able to snap an image just as that balloon was rupturing. And so if you watched all the way to the end, let me know by making a comment down below, Eagle 10. Okay? Guys, I really appreciate you tuning in this week. I'm having a lot of fun with this. If you're enjoying this, give me a thumbs up, because that really does help me. Helps me score better in the algorithms and get more viewers if you guys are giving me thumbs up. Also, if you've not subscribed yet, go ahead and subscribe to this channel, and think about sharing this video with other people. This is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.